right, welcome. Today we're going to continue looking at some various types of functional groups. We had focused on one specifically that contained carbonyl and hydroxyl groups yesterday. Today we're going to look at some that contain varieties of substances, some that might just contain oxygens, or they might have nitrogen attached, or even possibly halogens. And we'll look at how we go about naming those different kinds of groups. At the end of our discussion today, you will receive a sheet of practice problems that will give you a chance to practice naming several of them. And then, like I said, you will be taking a practice quiz at the end of this week. And then from there, we will be looking at reactions, dealing with them next week when I come back. All right, so with that in mind, let's look at the next group. It's called an ether, what we see attached. So an ether would have an oxygen, and then attached to it would be two carbon groups. So it would look something like this. Now notice the O, so you picture what's on either side, and we could draw an R, right? Remember, R simply represents a hydrocarbon group attached to it. In terms of naming it, we name it basically as an ether. And so what we do... So simply what we do is we name each of the groups, and then we put ether on the end. So we name each hydrocarbon group. So name each hydrocarbon group and put ether on the end. Much like what we did in organic with looking at the carbon functional groups, we would put them in alphabetical order. So let's just take a look at this one, for example. Notice that we've got the O in the middle, which means we've got a group on the end, and we've got a group over here. So let's talk about what our two groups are. Notice this group with one carbon is a methyl group. This group with three carbons is a propyl group. And so how do we name it? Well, again, alphabetical order, so we're going to say methyl, propyl, and then ether. And that's it. Now, again, how would we be able to identify that this is an ether? We would simply look for an O bonded to two different functional groups, and that would be it. All right, so let's continue on. Halides, or organohalides is oftentimes what they're called. And that just simply means that we have a halogen attached at one end of the molecule. How would we go about naming it then? Would simply be by using a prefix with an O ending. For example, by saying something like chloro or bromo or fluoro or io, simply to identify that we've got that in the molecule. Much like what we did when we identified methyl and ethyl and so on in functional groups. So, all right, let's go about naming this hydrocarbon with halogens attached to it, or organohalide. First thing we're going to want to do is notice that it is an organohalide because we've got the chlorine and the fluorine attached at some point on this molecule. The next thing we're going to do is notice the parent chain, right? So we see our parent chain, which is right here, and the question is, where should we start? Well, much like what we did for our functional groups, we're going to start with we're going to basically start alphabetically. So we're going to start with the smallest or the lowest alphabetically, or the first, if you will, that we come to alphabetically, which would be chlorine, which means we're going to start on the left side of the molecule, and we're going to call this carbon 1, carbon 2, carbon 3, and carbon 4. Now, it should be noted this fluorine probably should be better drawn, but this fluorine is attached to this second carbon right here. All right? All right, so then going about naming it, we're going to name it just like we did with the functional groups for... So then going about naming it, we're going to name it just like we did with the functional groups for hydrocarbons. And so in terms of naming, we would simply say this. We would say 2-chloro, because again, we started on the side closest to the chlorine since it's the first we get to alphabetically. Then we would say 3-fluoro, again, because after the chlorine, we see the fluorine is on the next hydrocarbon. And then we would say butane. Again, the numbers identify the location, so 2-chloro, 3-fluoro. Butane identifies the hydrocarbon parent chain, and we are done. That's it. All right, amines. Amines are very similar in terms of looking at how we would go about naming them. The only difference with amines is now we're going to see nitrogen. Anytime you see the AMI, it could be amine, it could be amine, it could be, we're talking about amino acids, we're going to see a nitrogen involved somewhere in that molecule. Now, a perfect example would be the one you see at the bottom, and let's look at how we would go about naming it. We would simply say whatever we have ending in amine. So we would say the group we have, or the group of hydrocarbon, and in the suffix amine. So looking at this hydrocarbon group we have, we see that we have 3 carbons with the nitrogen and hydrogens attached. So you picture your amine, you've got an R here, you've got 2 hydrogens attached in this case, and so then it's just a matter of naming it. So then what we get is this. We get propanamine. Propanamine. Again, we name the hydrocarbon group and end it in amine. All right, amino acids. Amino acids actually have 2 things attached to hydrogens with a carbon, and then they've got the carboxylic acid subgroup. So you see, again, over here you see the amine, over here you see the carboxylic acid, and then here could be any number of things. It could be any number of hydrocarbons attached to it, just depending on what the amino acid is, and that's it. That would be an amino acid. Naming it is extremely complicated. You'd have to memorize the names, and I'll give you a chance to look at those. I will be giving you a page of the amino acids when I get back, because we'll be looking at them when we talk about reactions that produce amino acids. And so when we look at that, I'll give you a page of the various amino acids. If you have Bio 2, you probably learned many of the amino acids. You might have had to memorize them, or you might have done a section where you just talked briefly about them. And you'll also get more into them when you get into college, and you talk about them in organic chemistry, as well as if you were to take a biochemistry class. All right, so let's keep going. Esters. Esters are another kind of functional group, and they'll look something like this. Now you notice that they kind of look similar to a carboxylic acid. They kind of look similar to a They kind of look similar to a carboxylic acid. The only difference is with the esters is that we actually will see a functional group, or a carbon group on each end. So instead of it being an OH that's coming off of like the carboxylic acid, in an ester, that O will have another hydrocarbon group attached to it. In terms of naming, we call them OHs. So we picture what we have, kind of like with ethers, we name each of those functional groups, and then we give the ending OH on it. For example, let's say this was our ester. Now, in terms of understanding what we have, this is where our double bond O and our O is, which means this is our parent chain. So that right there is our parent chain, which means this is really just a functional group as well. So notice what we say. We say propyl. For the functional group we have, this is coming off of that O. We say methane for our parent chain. And we say OH because it is an ester. Again, we have propyl, methane for our parent chain, OH. Now, how do we know where the parent chain is? The parent chain will be what has the double bond O attached to it. Whatever has the double bond O attached to it, that will be our parent chain. All right, let's do one. And we'll come back to amides in just a minute, but let's do one. So go ahead and name this carbon compound for me. All right, in order to name this, the first thing we're going to want to do is notice the parent chain. So the parent chain is going to have to be this. Now, again, remember, the reason we're going to identify this as the parent chain is because that's where the double bond O is. The double bond O will always be on the parent chain, which means this is a functional group. Now, this functional group with 2 carbons is called an ethyl group, right? So we know this is an ester because of the double bond O in the O, which means it's got to have the ending OH. We know that there's an ethyl functional group, and we know that the parent chain is really just propane, right? So in terms of naming, what are we going to say? We're going to say this. We're going to say ethyl, propa, because that's our parent chain, and then OH, because it is an ester. Again, ethyl, because of the functional group, propa, because that's our parent chain, and then OH, because it is an ester. All right, I want to go back. I want to show you one more type of functional group, and then when I'm finished with that, Ms. Goulson is going to pass out to you your functional group packet. It's really just a set of practice problems that is going to give you a chance to practice looking at all of them together. Now, there are some functional groups that we didn't spend time discussing in class simply because of time, but you will get a chance to at least see what those functional groups look like. You won't necessarily spend any time naming them because we won't be looking at any of them in terms of naming, but you have practiced naming a few of them simply because some of the functional groups that we didn't look at are actually polyatomic ions, like things like thiols. And so you will see a little bit of them, or you have seen a little bit of them, but you won't have to worry about naming the ones that we don't actually discuss in class. So with that in mind, let's look at one last one, and that was amides. Now, biggest thing to notice with amides, first of all, notice there's a little bit of a combination of things, right? First of all, notice the carbonyl group that's attached with the amide. Notice the amine section to it. So we've got an amine section, we've got a carbonyl group making this an amide. So notice what we have. For example, in methanamide, notice we've got carbon with the carbonyl group and the amine group attached to it. Only one carbon, which is where we said meth. And then we gave the ending amide because of the carbonyl group and the amine group, which combine together to make an amide group. All right, y'all, that's it. Those are the ones that you are responsible for knowing. So you think about the ones we've done. We've done alcohols, aldehydes, ketones. We've done organic acids. We've done esters, ethers, amines, amides, and organohalides. You are responsible for being able to name any compound that has those groups attached. And they can become more complicated. You'll sometimes see those groups combine to form larger substances, like larger compounds. You're going to get a chance to see some of them in some practice that you're going to be doing at the end of this week. But other than that, that truly is it in terms of naming and organic compounds. So with that in mind, I'm going to go ahead and stop the video. But before I do, let me remind you of a few things. One, you're going to get a practice problem sheet. This practice problem sheet is going to give you a chance, like I said, to practice naming these compounds. Then the next few days you're going to be doing an activity that's going to give you a chance to practice making these compounds. So as in, you think about in chemistry 1, you probably did, or you should have done some ball and stick models with some various compounds when you were practicing the idea of molecular geometry and naming covalent compounds. And so you're going to get a chance to practice doing that tomorrow. You're going to be given a set or a kit of balls and sticks. Those are the molecular models that you can make, and you're going to be asked to make one of each of these compounds using those molecules, and then practice just looking at them and seeing how you would go about naming them as well. With that in mind, then, like I said, you will take a practice quiz at the end of this week on this material, or it might be on Monday of next week. I can't remember. You'll have to get with Miss Golson to see where y'all are at to know when you'll take that practice quiz. And then you will be combining these to do chemical reactions when I get back next week. I hope you have a great day. That's it.